Hello and welcome. In this video, we're going to talk about calculating large quantities of data using Microsoft Excel. This is the third video in the Excel series that I'm creating for your help or for you to use to help you in your physics write-ups. So sometimes we want to look at calculating data or calculating quantities for very large sets of data. And so in this case, we're going to look at the same kind of problem that we had before, where we calculated the velocity of a ball as it was shot straight in the air. But now I want to know, well, how far will this ball go if I start changing the angle of the launch? And I want to know it to a degree of, well, let's go every half angle or half degree in the angle. And so what I'm going to do is I'm going to start by setting up my columns. And so if I look here, I have all my equations over here, things that I need to know in order to figure out how far it'll go for every angle. And so I'm looking for, this is my primary equation right here, and this is the one that I want to end with, is I want to end with how far it will go, or my displacement in the horizontal direction, and that's going to be my initial velocity in the horizontal direction times my time. Because the initial velocity is also equal to the final velocity in the horizontal direction for an object in projectile motion. So in order to do this, I have to figure out each and every one of these aspects. So how far am I going, or how fast am I going horizontally, and how long am I in the air? So I have to come up with a fairly good amount of data in order to calculate this for every half degree. And so the first thing that I want to do is I'm going to start with my degrees, or my angle in degrees. And so, so I'm going to start with 0 degrees, because that's where I'm going to start with. And let's go to 0.5. Now, one thing on Excel is that if I want to have it auto-populate or auto-fill in cells, then I have to give it a range. And so in this case, I'm telling it that I want it to add a half a degree every time I go up. And so as you see it, the number changes by half a degree. And let's go all the way up to 90 degrees. So we're going to go down here, and we're going to scroll all the way down to 90 degrees, and it fills it in. All right. So now that I have my angles in degrees, well, one thing Excel does not like, and Excel does not like degrees. It likes to use radians, which is another way of measuring angles. And so we have to convert our degrees to radians because, well, I like to use degrees. Our projectile launchers have degrees. Projectors or protractors use degrees. And so, so I like to have my independent variable, or I like to have what I'm changing in degrees. And so, so in order for Excel to use it, though, I have to look at, well, what are the radians of this? And so I'm going to go ahead and type in my equation here for radians, which says the rate. So it's going to equal, and there's a function called radians. Now what this does is it converts degrees to radians. And so I'm going to go ahead and convert all of my degrees to radians. Now in this case, I only have to set it up for the first one. All right. And then I'll show you how we actually are going to populate all the way down. So I'm setting my equation up to say that the radians of, or this number, is going to equal the radians version of that degree. And so I just click enter. And if you want to see if it's working, it gave me 0 here. It's hard to see that, but if I scroll down one, it fills it in, and so it's 0.01 radians. And we'll fill it in the rest of the way later on. So now I have my angle in radians. Well, now I want to know, well, what is my horizontal velocity? Well, my horizontal velocity is going to be given by my total velocity times the cosine of my angle, and in this case it has to be in radians. Now, in order for me to get my total velocity, I'm going to go back to this other spreadsheet, and we wrote down that the initial velocity was 5.35 meters per second. So I'm going to go ahead and write this in here as 5.35 meters per second. So now that I have my initial velocity put in, I'm going to go ahead and set up my equation. Now I know that my horizontal velocity is going to equal this number, 5.35, times cosine, right, of my angle. And so I'm going to click radians, and then I'm going to click, and then I'm going to close it. Now here's the deal. Whenever I start dragging these boxes, all right, watch what happens. All right, so this tells me that it uses box C5 as my initial velocity. But the next one down here tells me it's going to use C6. See how it drug the box down? Well, I don't want that to happen because I want this 5.35 to remain constant. So whenever I come up here, I'm going to click right in the middle of it, and then I'm going to hit F4. Now what F4 does is it locks the cell. It says that I want you to use this cell in every calculation, no matter which direction I drag this box. Now, it puts dollar signs in there saying that this is a locked cell. Now I can either just lock, I can lock to one individual cell, or I can lock to a particular column. So let's say that if I drag over, then it doesn't drag with me. It stays in that column. Or if I drag, I can lock it to one row, which is the second one right here, which tells me that I can drag down and it will stay in that row. So, but in this case, I want to keep it a constant 5.35 for all of my calculations. And so I put F4 and it puts the dollar signs in there, or you can just manually put the dollar signs in yourself. And so now whenever I drag down, watch what happens. Well, it didn't change, but as I go down farther and farther, you'll see it changing. Now the next thing I want to know is using this equation right here, and that is my vertical velocity. I need to know that also. So in this case, it's going to be my initial velocity times the sine of the angle. So it's going to equal my initial velocity. And then I'm going to hit F4 to go ahead and lock it in place because I don't want that to change as I drag the cell, times sine of my angle in radians. Now, whenever I drag this down, the radians are going to be changing, and so I want it to be able to move. I want it to drag down with it. All right? And so if I drag that down, look, I'm starting to get more velocity in the vertical direction. All right, let's go ahead and move those back so we can get them out of the way. Now, the time column is a little bit harder. And that is, I have to use this equation right here where my displacement, my vertical displacement equals my vertical velocity times time, plus 1/2 the acceleration of gravity times time squared. Well, that is one of the kinematic equations we have. But in this case, we might not always be shooting with a displacement of 0. In other words, I might not be going up and then coming back down to the same spot. And so I have to figure out, well, how can I show that maybe my vertical displacement is changing? And so that is what this box right here, the vertical displacement equals. That's because in this case, I can enter in a value. I'll be able to enter in a value and then have that value change my calculations. And so if I've given a scenario where I have to shoot up, and so I have a positive vertical displacement, I can enter that into that box, and then it's going to calculate my times for everything else. Or if I have a value that, let's say I'm shooting down. So let's say I'm on top of a hill, and I'm shooting down maybe a water balloon down onto some targets down below. Well, I need to be able to enter in a negative vertical displacement so that I can calculate the times that it will take to hit that target. So I have this equation, but I need to rearrange it into something like this. Now this is, I just took this displacement and I subtracted it to the other side, and then I rearranged it so that it was in this form. And if you look, this is exactly a quadratic equation. We have an A next to a variable squared, we have a B next to a variable not squared, and then we have a C, or a constant, that doesn't have a variable associated. So in order to use this, I have to, or in order to solve for this time, I have to solve using the quadratic equation. Now, usually you'd run this twice. You run it for the plus, and then you run it for the minus. And so the quadratic equation, you'll have one of them that says negative b plus the square root of b squared minus 4ac all over 2a. And then you'll have a second one that says negative b minus the square root of b squared minus 4ac divided by 2a. Now, I'm going to tell you right now, I've already done this enough times to know that if I were to put positive in there, I would start getting negative times, and negative times are bad. So in order to keep the times positive, then I have to associate with the negative or the minus here. So I'm just going to do that one for you and show you how to enter it in. Now this is the process to put this into the box right here. So let's go ahead and get started on it. Well, the first part of the quadratic equation says negative b. So if I look here, b is my initial velocity in the y direction. And so that is given by this cell right here, but it's negative. So I might click minus and then click on that cell because I want to use that velocity. And then I'm going to subtract. And then I'm going to subtract the square root, SQRT. And then don't forget to open parentheses this because I want to capture everything underneath the parentheses as being the square root. And I'm going to start with b squared. So here's b. Once again, it is my initial velocity in the vertical direction. And so I click on that. And then I want to show that it's squared. So I'm going to hit the caret sign, which is shift 6, and then type a 2. That means that it's going to be b squared. And then now I'm going to subtract. Now I'm going to subtract 4a times c. So I'm going to subtract 4 times a. Well, in this case, a is 1/2 g. So that's 0.5 times g, which is negative 9.81. And then it's also going to be times c. And c is negative my displacement or my vertical displacement. So times a negative, and it's going to be this box right here. Okay, so that's going to show me that is underneath the square root. And then what I want to do is I want to take this whole top term, which is right here, and I want to convert it, or I want to divide it, not convert it, divide it by 2a. And so I have to make sure that I parenthesize, or I put parentheses around the whole top part, because I want to make sure that that is what's getting divided by the 2a. And so I'm going to hit divide by, and then let's go ahead and put parentheses around the bottom. 2 times a, well, a is negative 9.81, all right, times a half. So it's g times a half. All right, and I'm going to go ahead and close parentheses there. And I'm going to hit enter. And so if I'm at 0 degrees, well, I'm in the air for 0 seconds. All right. Whenever I drag this down, we're going to run into an issue. And that issue is that this C4, my displacement here, well, I don't want it to change. I want it to maintain the same number. So I'm going to hit F4 again to lock it into place. Now I want my velocities to go, because these velocities are going to be changing as I scroll down. And so I want to make sure that they change also. My A's, 1/2 G, is always going to stay the same. Okay, so I don't have to change that. I can keep those as solid numbers. The one thing that I do have to keep solid, though, is the displacement that I'm going. So if I hit enter, well, it's going to be 0. And then now you can start to see that I'm starting to get some changes. Okay, so now I'm done with the first row. All right, and I solve for my time. So now I need to know, well, what is my displacement? What is my horizontal displacement? And that is where this equation comes in. So for my horizontal displacement, I'm going to type in equals, well, it's going to equal my horizontal initial velocity, which is 5.35, in this case, which is E9, times my time. Now, whenever I pull this down, I want it to pull the horizontal velocity and the time in the same row as it. So none of these need to be locked. Then I'm just going to hit enter. And then once I have this, now it's time for me to do all the calculations at once. And so at 90 degrees, half degree increments, that's a total of 180 calculations. And watch how fast I can do this in. I just take it, grab the little box on the lower right, and I drag it down. Okay? And then once I drag it down, it automatically does all the calculations. So now I have the degree, or the angle of my projectile launcher, and I have a column of the range, or how far it goes left and right, or how far it goes forward. And as you can see, my range continues to move, and it goes up, and then it starts to go back down. And we'll start seeing how that works whenever I start graphing it. I'll actually throw a graph up here so that we can see what it looks like. Now, the way this works is once we have it set up, it's very simple. I don't have to worry about these columns. These columns are all behind-the-scenes calculations, and so I'm going to go ahead and black those out because they're just a distractor. So I'll black them out so we can't see them. Okay? And now let's say that I give you a target. I give you a target that is, let's say, 3 meters or 0.3 meters, 0.3 meters below you. Okay, so it's 0.3 meters below you, and I want to know how you're going to set your projectile launcher in order to hit that. Now, if you notice, some of these went to an error sign. This means that at 0 degrees, you will never hit an object that is 0.30 meters below you if you have it set at 0 degrees, right? Or there's no range. You can never be that close. And so if I scroll down, then I start seeing here. I can hit targets that are 1.24 meters away. I can hit targets that are 2.57 meters away. I can hit targets that are, here I can hit targets that are 0 meters away. But I have to shoot up. So if I have it at 0 degrees, I cannot shoot. So if I have it horizontally, I cannot shoot a certain distance away. So in order to get those closer distance, I have to look at angling up higher. So if I were to take this and graph it so that we can see the different ranges that I could hit, all I do is I highlight these, and we'll go over graphing more in detail later. But right now, let's just look at the areas that I can hit, and I'm going to hit a scatter plot, and let's go ahead and do this. And as you see, here's my graph. Let's move it up. We can get it up here. And as I see, then these terms right here are these angles down here. Let's add some labels. This on the bottom is going to be angle. And this on the side is going to be meters or range. Well, it means that my angle, I can't actually start hitting anything that is 30 centimeters below me until I start getting up to here. And then I can start hitting these different ranges, and then I can even come back and hit closer to me as I get higher above. It means that also that if I look here and I were to draw an imaginary horizontal line between my data or on my graph, if I were to draw a horizontal line here, so let's say my range is 2 meters, well, I can hit it with two different angles. I can hit it here around 32 degrees, and then I can also hit it here around 66.5 degrees. I can hit the 2 meters, or 66, 67 degrees, somewhere around in there. And so it means that some of these have two different angles that I can hit the target with. Now, if let's say that my displacement, my vertical displacement was 0, well, then now that I look at here, I can hit them with all of them, and all targets have two sets of degrees that will hit that target. Now, if I were to make you, let's say you wanted to shoot up, well, we run into the, so we're shooting up above, so we're shooting up a hill. So let's say I'm going to shoot up 20 centimeters. But once again, there's no way that I can shoot up with my velocity up above 20 centimeters with these values right here, and those go probably all the way up to 21.5, somewhere around in there. Yeah, so 21.5 degrees and below, I cannot hit anything that's 20 centimeters above me. But then I can start seeing that I can hit those objects by changing my angle, and I can shoot up to a range of 0. In other words, I can shoot right back on top of myself 20 centimeters above if I go to 90 degrees. So if my target is directly above me, 20 centimeters, I can shoot up to that target using 90 degrees. So now that we've looked at how we set up these equations inside Excel and calculating these large quantities of data, dragging equations makes it a whole lot easier to create or to do numerous, thousands of calculations with only having to type in the information for one. So you're going to want to keep this in mind. There is a lab like this where I'm going to have to give you a target, and I want you to shoot it using the projectile launchers. And so you need to know how to set up Excel so that you can set up this lab and be able to find out where these two things hit.